Hello, I'm Simon Bowes, and this is the Net Hero podcast. But before we start, check out the brand new futurenetzero.com. We've completely revamped the website platform. It has an extra 2 areas that will really help you out. One is the index, which is an index of technologies to help you understand what's out there right now to help your business or local authority or public sector organization make the difference. Technologies made simple. And the second is our learning toolkit that'll help any business go from zero knowledge to getting their carbon footprint and beyond. Our aim is to help you take action, put net zero in action with our new platform. The podcast, of course, continues to go from strength to strength, so make sure you keep subscribing. We want to tell your stories, big or small, doesn't matter who you are. If you're a business, you're an academic, you're a campaigner, if you're doing anything that's trying to help us cut our emissions, come and tell your story on the Net Hero podcast. Now, on to this week's episode. Shrooms, fungi, mushrooms, whatever you want to call them, they're everywhere. But in fact, this is one of the sad things about my life. I actually did a degree in microbiology, and I was told that they're not plants or animals. They sit in their own little place. Now, most of us see fungi as either something we eat or a pest that's growing out of damp corners of our houses or on wood or trees that you go for a walk. But actually, could they be a key to creating net zero building materials? Could they help us by also getting rid of plastic waste? Well, that's what an innovative company called Biome is looking into. And I'm delighted to say that the boss of it, Ahab Saeed, joins me now. Ahab, hello.
Hello, hi, thank you for having me.
No, my pleasure. So look, let's just talk about fungi because it is quite funny. I mean, there are people who eat them. Some people take them for another reason, to get a different view of life. They're seen as just disgusting things that grow in cupboards, but they play a very big role in nature. Before we go into kind of what you're doing, which I think is fascinating, why is fungi or mushrooms, all of that? Why are they interesting for you? Why do you think they're an interesting thing to look at?
I think fungi are one of the most wondrous organisms out there. And I say that because they're almost alien.
Yeah, they are.
For long, biology categorized them as plants, and then, we didn't realize what they actually are. We're finding so much about them. And the properties and capabilities within the group of organisms that is the kingdom of fungi are just mind-blowing. They can control the minds of other organisms. They can, completely transform ecosystems from the ground up. They're nature's janitors. They are the source of circularity within the nutrients that are circulated in nature.
It's incredible. And also, I suppose most people wouldn't, maybe they do, or maybe they don't know, we wouldn't have antibiotics without fungi.
Absolutely.
And that's one of the greatest things that fungi have given us over the last 80 odd years is,
Yeah.
the ability to keep us going. So you are not a biologist, you're an architect, or you're from the sort of building world. So give me a little background of why you wanted to look into these amazing, I don't even call them creatures, let's just call them fungi, these things for buildings science. Why did you want to explore? Did you know about this in architecture school? Is it something that you came across, or how did you get the connection?
Yeah, so I started my higher education in design engineering,
Right.
and I've always looked to nature for inspiration. I know that nature's got billions of years on us and what we can develop and create. And looking at how technologies have evolved in the natural world, how they have learned to adapt to different needs, really gives us insight into the strategies that we can integrate into the products and the projects that we're working on in order to really achieve a holistic solution with what we're creating. And every time I find I've got a wicked design problem,
Yeah.
I look at nature as the source of inspiration, as the measure that I can compare my designs against, and as the mold that I can base everything I design to, but also as the mentor that can guide me throughout the entire design process.
So before you got into the fungi, what other things from nature have you used to help you design what, basically?
I've looked at making wind turbines 27 times more efficient than they are currently by studying how bacteria actually process their metabolism, how it works. Uh,
Wow.
Looked at how we can create very aerodynamic products and technologies and vehicle design that can, just slight changes in design can achieve amazing efficiencies in terms of speed and effectiveness of fuel use. There's just so many different things that we walk by every day in the park or in our gardens that we don't really realize are just radical technologies that have taken billions of years to evolve. But what led me to fungi was looking at the most successful insulating materials in the construction industry,
Right.
which are also some of the most harmful to our
They
environment
are.
and
Yeah, absolutely.
and I looked at their structure and I looked at what kind of levels of bubbles or porosity in that material are required to achieve the thermal conductivity for the industry. And started to compare what structures in nature are also giving us these similar structures. And I
Right.
found that fungi can create the most interlinked webs under the soil, under the ground. It's actually what holds all the topsoils together in forests. The largest organism in the world is a fungi that spans across an entire forest. I mean, it's just mind blowing. And then when you realize that you can grow that in a confined space and create the most insulating material potentially, but then not only that, you can grow it in a liquid form and then extrude that into the form that you're looking to produce or the material you're trying to create. It just opens up a whole other way of manufacturing.
Sorry, I want to tell you about it. It's
Yeah, yeah.
fascinating, but were you just walking around and yourself dug up and had a look at fire? I don't even know how I would even think about a rock wall or some sort of like insulation foam, and suddenly think, I wonder what fungi are doing around that. How did that connection happen?
I think the next time you're in a forest, just
Right.
pick up a piece of log, a dead log that's on the ground,
Yeah.
turn it upside down. You'll see the little hairs, the white hairs of
Yes,
fungi.
absolutely. Seen a million times.
Exactly. And then that's kind of where the inspiration started. And then when I did research on whether this has ever been done before or used before, you can see tribal peoples using it and indigenous communities using it for millennia. And they've been using those to fix pieces of wood. They've been using fungi to create actual clothing and products and, hats
Wow.
in the Baltics. And I was like, okay, so this is actually something that's been explored. And then there's a company in America in 2006, 2007 that used the technology for packaging as well. So I thought, okay, this is, something that has been explored. So let's try and see if we can grow it ourselves and what we can create. And within 2 or 3 years, we filed our own patent, we had our own technology and went from there. So it was really a curious exercise, but then standing on the shoulders of giants who have already explored this before us.
So, what is the insulating material that fungi make? What is it just because they mat together or how does it compare to something man-made? Like, we've all seen insulation boarding that goes up on the wall, or we've all seen that kind of material like rock wool or that, the sort of
Mhm.
fiberglass that people would put into lofts for insulation. What does the fungi make? Is it just strands, or do they make a kind of like a solid material?
Right. So if we think of the mushroom,
Yeah.
that's like the fruit of the organism. And then
Okay.
under the mushroom is the entire root system of the organism. Just like a tree and its roots,
Got you.
mushrooms are very similar. Those roots are what we use in our technology and our product and in most
Ah,
mycelium or fungi-based products out there. You basically take that root and you can then multiply it, self-multiplying, so you can multiply it infinitely, and you can continue to harvest it and use parts of it, and then that will then grow infinitely on any food source that you provide it with. So we take waste streams from agriculture,
yep.
from food, from even urban mining, and we introduce those to our strains. The strains begin to inoculate or consume that substrate or the feedstock. And then as it completely consumes it, you can dehydrate it and you end up with a panel that is comparable to a plastic composite material or a
Oh, so
foam
so
material.
basically you're taking the roots, they grow, and then you
Yeah.
dehydrate them and turn them into like a board.
More or less, yes.
Wow.
That's generation one of our materials. And now we're actually exploring a complete reimagination of that, where we, from scratch, creating the foam structure without even using the roots at all, by having the fungi itself be embedded in the paste or the material that we're using to make the foam. So
Okay, quick question. How does it compare to the man-made products in terms of its efficiency and how much kind of insulation it provides?
yeah, no, that's a great question. That was really the turning point where we started to have the construction industry begin to take us very seriously. Stop thinking of us as a bunch of hippies with
Yeah.
hemp and mushrooms
I was
to
going to say, have you been eating too many of your own mushrooms that you have?
and we started to get taken very seriously because we tested them against industry standards
Yes.
and we were outperforming the plastics, the wools, the materials that have been established in the industry for decades.
Wow.
And it just really started to change people's perceptions that this is really a serious technology that can compete with what we've been using for 40, 50 years in the industry. So, in terms of fire performance, we're
Yes.
outperforming the plastics significantly. So, plastics are around an F rating. We're hitting a D rating without any kind of treatment. And with treatment, we can go to a B rating, which is the highest you can get.
To be sort of as flame proof as possible, so not to ignite, basically.
Exactly. Yeah. So A rating is like a mineral material that
Yeah.
doesn't burn.
Yeah.
We'll
Yeah.
never hit that
No,
because
of
it is a
course not.
carbon base. So we're hitting at about a B at
Wow.
best, a D at worst, which is, mind blowing compared to some of the most prominently used materials in the industry that are still at an E or an F. And the same thing with things like the thermal conductivity. So at a very small scale, lab scale prototype, we were hitting 0.02, 0.03. Those numbers don't mean anything to most people, but it's watts per meter Kelvin, and it's the thermal conductivity of
Right.
the technology. The plastics are between 0.02 to 0.03, and the mineral wools are 0.04, 0.05, and now they're getting better as well. So we're already comparable to industry properties. And then when we scaled the technology to full scale in West Somerset here in the UK, we were hitting between 0.04 to 0.05 on thermal conductivity. So it was no longer a concept or a sci-fi idea. It became a concrete technology that can compete with the likes of the plastics and the wool insulation that's already being used.
Have you? I know that you're not really a startup. Been going a few years, but you're trying to scale. But have you actually got any of this material in buildings being used commercially, and is it making a difference to people's energy bills and emissions and all of those sort of things?
So, in order for us to install our material into a building from the ground up, we will need the full scale accreditation. In
Right.
order to achieve the full scale accreditation, we will need standards that are fit for our material. To create a new standard, it can cost anything from 100,000 to almost 500,000, depending on the complexity of it. And so we've worked very closely with the British Board of Agromont to test our material and products against industry standards
Yeah.
in a way that doesn't mean we have to create our own one.
Okay. So you've been at sort of prototype level sort of thing.
Yeah, yeah. So
But have you
standards are
actually installed it in a real place, not right just in a
yeah,
lab, actually in a building?
yes, yeah. So we've got our panels used for acoustic insulation reasons or acoustic installations at County Hall in London.
Ah,
We've also got some in office buildings and in galleries.
mate, I could have got rid of all of this. I didn't know. That's
Yes, yeah.
exactly
Well,
it.
the acoustic performance of it is actually just below studio acoustics. So,
Wow.
and that's us again. We're not aiming for acoustic insulation as the main application. It's mainly thermal, but we just found that it's actually got really good acoustic properties as well.
So it can grow on anything, right? Pretty much. Yeah. Any organic material.
Yeah, you'll find a species that will eat something,
You'll need
anything
something,
you
right?
find. Yeah.
You can then harvest it quite quickly, and
Yeah.
you can manipulate it quite well to make these boards and things.
Absolutely. We manipulate it on three levels. On a genetic level, so we actually evolve the genes of that species and strain so that it gives us different properties. And then we manipulate it on an environmental level where we change the conditions that they grow in to give us different properties. And then we manipulate it in the normal traditional sense where you can post-process it and treat
Yes.
it to get even more properties.
So how long does it last? Because this is the thing. there's an element of is it good, efficient, does the job, but then if it crumbles after like a year or two, then no one's going to want to stick it anywhere in their housing, are they? So I don't know if you've got any sort of test results on how durable do you think this could be?
Yeah. Well, believe it or not, there is no test in the construction industry on the durability of a material. And even though plastics,
Really?
there isn't,
That's
there is
mad.
a test, no. And even though plastics are supposedly, they last for hundreds of thousands of years, we all know that,
Yeah.
the performance deteriorates after only 5 years. But what we're finding with our product is we're embedding something known as selective degradability, which means that as long as it's installed in a building and not in contact with the microbiota of the soil, then
Yes.
it will last for 30 to 60 years. If it is in touch with the microbiota of the soil, it degrades within, and that's because the use environment is very different to the end of life environment. And we
Gotcha.
create technologies that are recognizable by nature that will be able to be conducive to life at end of life and degrade and break down, but during their use environment, last and perform just as well as our synthetic counterparts.
Another area you're looking at, which I think is exceptional, is I mean, it's funny. I just had a conversation on another podcast all about plastics and kind of what we should do with plastic because, they are not evil. Plastics are great. They've done so many. Look at the pandemic. You'd never have got through the pandemic without plastics and face masks and all of that. But they are one of those hazardous things that get a very bad press because they take a long time to break down and there are so many different kinds. Is it true that you found a kind of fungus that might eat the hard to recycle, hard to break down plastics?
Yeah, so in 2018, we had a jar of fungi growing in the back of what was a tent back then, a little tent in the shipping container and shipping ship. And it was just forgotten in the back of the tent. It was growing there for 2, 3 months. There's a little plastic sponge on top of it that allows it to breathe.
Yeah,
We realized the mycelium or the fungi decided to grow out of the jar, completely engulf the sponge. And we're like, oh, what is it feeding on? The
yeah.
food source it's left its food source. And we cut it open in a pitch to Waitrose because we had some inclination that it may be consuming the plastic. And we pitched to Waitrose and partners for their planned plastic prize. Cut it open in front of them, and there was no sign of the sponge inside. There was just barely a silhouette of where the sponge used to be, and it was completely gone.
So it actually can digest the plastic.
So at that point, we weren't sure.
Right.
So we received funding from Waitrose and Partners and from Power to Change is about £700,000 to further explore this as well as build the full-scale facility for our insulation
Yeah.
product. And when we further explored it, we ended up developing 4 different strains of fungi that can consume anything from polyurethane, polyethylene, polyester, polystyrene, and we were able to demonstrate degradability within 28 days to the point where the plastic was no longer recognizable under a chemical analysis.
What do they turn it into? Do they turn it back into the kind of hydrocarbons that, the oils that plastics come from, or do they just eat them?
Yeah, kind of. I mean, if you think of plastic as just a very complexified carbon,
Yeah.
plastic,
Yeah.
of course, it's an artificial human-made material, but it is still very natural at its core. It's just a very complexified carbon source. So
Yes.
the fungi knows how to break that down. It secretes all of its
Incredible.
enzymes. It breaks it all down into sugars and hydrocarbons, and it releases carbon dioxide in the process.
Okay.
The sugars are consumed by the fungi. The hydrocarbons are partially consumed, and if given enough time, the fungi will consume it over time. And then the carbon dioxide is photosynthesized back into oxygen, turned back into oxygen on site. So the entire process is completely closed loop, and you're actually eliminating the plastic completely. So you're not propagating the production.
Have you tried this out then in a test scenario where you've got a bit of plastic, shove them in there in a room, get on with
Yeah.
it, and then the CO2 that's you've got plants there
Mhm.
that are feeding off the CO2. Is that what you're doing?
Well, yeah, we've worked with British Land and Bupa on 2 separate projects. With Bupa, we looked at face masks and plastic gloves from care homes
Yeah.
in degrade. And with British Land, we looked at polystyrene packaging and how we can degrade that. And with the polystyrene packaging is when we got the result of after 28 days, the plastic couldn't be recognized as a plastic. All of the chains have started to break down. And so we're estimating that the duration of the degradation will likely be around 4 years. And throughout those 4 years, whatever the mass of the plastic is, you're actually harvesting additives for antibiotics and drug discovery that are very valuable for the pharmaceutical industry, but are currently derived from harsh chemical processes.
Couple of quick questions. This is like
Yeah,
fungi quiz time. Where do you
sure.
get them from? What's are they native to the UK? Are they from certain parts of the world? Are they? You talked about some genetic manipulation. Are they ones that you grow in the lab?
Yeah, so most of our species and strains that we work with are harvested from or foraged from the South London forests.
No way.
Yeah, so we wander around the forest, we go on foraging trips. Also, team members on their own just go on a foraging trip.
So you're just knocking around Epping Forest or anywhere wherever you are, just have a look
Yeah,
at some fungi and then go, why? Look at, can eat a bit of plastic.
take a little specimen back to the lab and multiply it and study it.
Hey, you haven't taken any mushrooms before this interview, have you? Just checking on
No,
this.
I have not today.
I mean, this is incredible stuff. It really is.
I think, yeah.
No, I mean, it's just you've got something. I mean, you're right. Fungi are so not understood, in
Mhm.
science. We've really struggled, as you said, didn't even know where to put them. They've probably got amazing properties, and you're looking at things like the digestion side and the construction side. Obviously, I hope you can scale and get to a some sort of commercial product. But what do you think this could do? This kind of fungi-based net zero technologies. What could they do to
Yeah,
help? The ultimate goal, which is to cut our emissions and keep our
absolutely.
temperature down.
Absolutely. So the technology itself is actually carbon negative. You're consuming more carbon than you are releasing into the
Right.
atmosphere as part of the production process. So large multinationals, by replacing a plastic product or technology with a fungi-based product, and I have to also stress that not all fungi-based products will have the carbon negativity
Of course.
associated
Yeah.
with it. Because as the fungi is growing, it's actually releasing
The
carbon
CO2
dioxide,
you said. Yeah.
and so our process creates that closed loop system. And by doing that, you're decarbonizing your supply chain. And every factory that we create with our licensees, we contractually oblige them to put a profit share to the local community within 100 kilometers of each factory. So you're actually getting people out of poverty, you're supporting the social impact and the economic impact within the local context. And you're able to actually hit many of your, say, ESG reporting targets by just simply replacing this one plastic or this one product with one of the fungi technologies.
How many factories have you got, or are you still again in the test sort of stage?
We're currently in the process of signing our first global license
Right.
to apply the technology to building insulation. And this is to be done with one of the largest construction firms globally.
Yeah.
And they would be replicating that technology across factories
On site there.
around
Right.
the world. Yes, yeah.
You're still very much the R&D company. You're coming up with it, and then the idea is not that for you to have factories that make this stuff, but to take the technology and offer it to other people who are using plastics in the general work they're doing.
That's correct. Yeah, we work with major brands and
Gotcha.
multinationals, identify where their weak spots are in their supply chain and replace that. And we do it in a way that's holistic. So we're not just focused on carbon, we're not just focused on particular categories. We're looking at the full picture from the social, economic, and environmental perspective.
People have started to look at nature, like you talked about earlier on.
Mhm.
Bamboo, right? People are trying to look
Right.
at bamboo for construction, other types of wood. They're looking at different things going back almost to before we had the Industrial Revolution
Mhm.
and the big oil and gas expansion that changed our world. Where do you think this technology can go in terms of making a difference in the poorer parts of the world, in the parts that are actually more vulnerable to climate change? I know you said earlier before we
Mm.
record, you're from Egypt, my family are from
Yeah,
India. You go to those countries, there's a lot of plastic waste. There's a lot of stuff that's just dumped into rivers and things like that. It's all very well making these things in the West where people are already more environment, and not, I wouldn't say they're more environment conscious. They've got the ability to do something, whereas people are still trying to survive in other parts of the world. Do you think some of what you're trying to do here could make a difference in those sort of developing nations or nations that need some help trying to deal with this plastic waste problem, which is really on their doorstep.
Yes, I mean, that was really my core driver of starting Biome and developing these technologies, is to address some of the major challenges that we're facing around the globe and focus primarily on the global south. And the reason for that is where the impact is felt the most. That's where the majority of the world's waste ends up. That's where a lot of the health, environment, and economic
Absolutely.
challenges are being faced. However, as a very small company, and I know from my personal experience, from being from Egypt, it is really challenging to set up
Mm.
in those
No, I get
economies.
it. I get it.
There's a lot of challenging politics and bureaucracies
A
that
lot
are
of
really difficult
bureaucracy.
to
Yeah,
get
absolutely. Yeah.
around. So the idea is to reach a point where we are stable as an organization within the global north, so licensing our technology to the applications that are prominent within
Mhm.
those countries, and then adapt them towards the global south, as soon as we are able to. However, nothing that we create is a premium product. There's nothing that I hate more than seeing an amazing technology being sold at an
Price that.
extortionate,
Absolutely. Yes.
yeah, and only used in high-end skyscrapers or
Yeah,
things like
yeah,
that.
yeah.
So,
So are you hoping as you develop this stuff, you know, I've just had an extension being done and
mhm,
tried to get as many bits of kit that was low kind of carbon as I can, but it's not
mm,
easy. So there is wood
yeah.
in it, but there's still insulation materials. I'm not going to lie. They've had to
Mhm.
get that sort of stuff. 5, 10 years from now, I might be able to build that sort of thing. Instead of MDF, I could be using fungus boarding. I could build the structure. I could insulate it with fungi-based insulation. Do you see a future like that not that far away, or are we still decades away from this?
So for our fungi-based materials, so insulation for buildings, for example, we're looking at a much shorter time frame than that. So we're talking 3 years before the first
Oh,
factory will be built in
oi,
Europe.
oi, I can go down to my builder's merchant and say, I'll have the fungi board.
Exactly. And then from that point, it's kind of an exponential growth across Europe and beyond. Many of the companies we're speaking to are already operating multinationally, and that's the aim really, is to work with a partner that can take it to many places. If we're talking about the plastic degradation, there are a lot of dangers associated with that technology in the wrong hands because it can be used as a tool to produce more plastic.
Yeah,
So we are targeting mainly pharmaceutical organizations that focus on drug discovery to cure major challenging diseases and ailments. And so that way we are using the plastic just as a feedstock or as an input material. And I guess, commercial benefit is to, pharmaceutical additives, things like that. So that it's not necessarily used by a plastic manufacturer or someone with a stake in plastic manufacturing as an excuse to produce more plastic, basically. So that's going to take maybe another 5 to 10 years before you see it being implemented
yeah.
uh, at a significant scale.
You've been working with this stuff, I think you said 8 years, is that right? Something like that?
It's almost 8 years now.
Yeah.
Yes. Yeah.
I mean, I don't know. Probably people are looking at this anyway. I don't know. I'm sure there are loads of people looking at fungi around the world. Do you think we've just not really have any idea where this organism could help us?
I think we've barely scratched the surface. When you think there's a potential 1.5 million different species out there, potential, these are the ones that we could potentially have discovered. And within each species, there are so many mutations and so many different things. And we've only actually worked with scientifically less than 10,000, or I think 15,000, something like that. So that just shows you the
The
scale of.
opportunity of what could be out there that could help us.
Exactly. Exactly. And we're finding now strains that can support brain function, that can cure all sorts of other illnesses and tragedies that people have really struggled with. We're finding strains that can be used to actually deal with metals, remove metals and be used as a filtration system within waters, and kind of the remediation properties of removing toxins and chemicals alone is humongous, and that's like there's so little research going into that. Because when you think about as well how research is funded, particularly within the Western world, there's got to be a real benefit to industries and economies. And there isn't much benefit, unfortunately, in remediating toxins and chemicals because that in itself is a huge industry.
Of
So us
course.
being a very independent company have the privilege to explore that further and put the time into it.
Well, I mean, fungi, I wish I'd carried on. Back in 86 when I was doing it, flipping out, I thought, God, they're so
Yeah.
boring. Wow. Have I got them wrong, hey? I will respect your mushrooms now from when you're out there.
Yeah,
It's been fascinating, Ab. Thank you so much for what
thank
you're
you.
doing. Best of luck with Biome. I think you're doing a brilliant job, and showing something that could really make a difference from such a natural material is exceptional stuff. Thank you for joining us on the podcast today.
Thank you so much. Really appreciate it.
What do you think about this story? I think it is fascinating. Drop us a line. You can get in touch by email, nethero@futurenetzero.com. If you've got a story to tell, then let me know. And also get in touch on social media. I'll catch you for the next episode coming soon.
You've just heard the Net Hero podcast from futurenetzero.com. Join us as we help you find ways to cut your carbon footprint as we head towards net zero. Subscribe and follow us on social media. futurenetzero.com. Better business, better planet.